Hey, what's up, Algebra 2? It's Ryan. Today we're going to be going over exponents and exponent rules. So, I think this lecture, exponent rules, is one of the most important topics in all of Algebra 2 because calc uses them a lot. And not in the sense that, oh, you're going to have to overtly use certain properties, but your focus is going to be on differentiation or something in calc. And so when you're given a problem where you're going to have to take the derivative, you're going to have to use all these different methods. But in order to simplify, or maybe as part of that method, you're going to have to use some of these exponent properties. And so it's really important that whenever you take calc, whether that's in a couple of years or whenever, you walk into the classroom on that first day and you have all of these properties mastered. So when you see a problem, you know exactly what to do, and boom, 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 you got your answer. So anyways, by the end of this lecture, hopefully we're on that first step in our journey to mastery of all of these properties. Okay, with that said, let's hop into this. So first, exponents, they're essentially just saying, how many times are we multiplying this base by itself? So for example, 2 to the third is just 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, so 2 to the third is 8. 2 squared is 2 times 2, which is 4. 2 to the first is just 2, since we're not multiplying it by anything else. And 2 to the 0th power is always going to be 1. Anything to the 0th power is 1. It essentially negates it. Now, when we have a negative exponent, as is the case here, that means we're actually going to take the reciprocal. So essentially, we're doing 1 over 2 to the first. And 1 over 2 to the first is just going to be 1/2, since 2 to the first is just 2. Now 2 to the negative second power is going to be 1 over, I don't know why it's not doing that, 1 over 2 squared, which I'm just going to write 1 over 2 times 2, which is essentially 1 over 4, 1/4. And 2 to the negative third is going to be 1 over 2 cubed, which is just 1 over 2 times 2 times 2, which is just going to be 1 over 8. Okay, perfect. So main things to get from this, when we raise something to the 0th power, that just results in 1. Anything, no matter what it is, except for 0, where it's undefined, that's an anomaly. And when we have a negative exponent, we're essentially just taking the reciprocal. So we're doing 1 over 2 to whatever exponent. Okay, so now let's talk about some properties. First, we have product of powers. So when we have two essentially exponential terms that have the same base a but different exponents, or technically they can be the same exponents, and we're multiplying these two parts, that gives us a to the m plus, those supposed to be an m, so I'll just do an m there, a to the n plus m power. So we add the exponents. So in this case, we have 2x cubed times 4x to the negative first power. Well, we can first multiply the coefficients. So 2 times 4 is just going to give us 8. And then for the exponents, we notice we have the same base same base x. So we're going to add the exponents. 3 plus negative 1. And this is just going to give us 8. And 3 plus negative 1 is just 2. So we're going to say x squared. Perfect. Now, if we have a power of a power, so we're raising a to the m to the nth power, we actually multiply those two exponents. Oops, sorry. This is kind of hard to do. M times n. So in this case, when we have 3x to the third and all of that raised to the second power, well, we actually need to distribute this squared portion to the 3, 2. So it's 3 squared, which is 9. And x cubed, we have a 3 on our exponent here. So we multiply 3 and 2 by this property. We get 6. So 9x to the 6th power. Okay. Yeah, just be mindful in this case that we have parentheses around both, around the 3x to the third term. So we do need to distribute this squared part. Okay, so now we have the power of a product rule. And essentially what this tells us is when we have ab to the mth power, we can actually separate these two a, b. And that's equal to a to the m power times b to the m power. That isn't good. Like so. Okay? And we just want to make sure this property, as with all of these properties, you should be able to go back and forth. So recognize when you have an exponent like x to the 5th, we can go back and say that's equal to x to the 3rd times x squared, because that might be important when we're simplifying a radical or something along those lines. So anyways, the power of a product rule, a times b in parentheses to the mth power is equal to a to the nth power times b to the mth power. So in this case, 2x would be our a, y squared would be our b, and we just separate those. So we have 2x, I'm going to write this out in 2 steps, 2x to the 4th power times y squared to the 4th power. Okay? And that's just separating them like we did here, and now we're going to evaluate it. Remember, we have to distribute this 4th, raising to the 4th power to both the 2 and the x. So 2 to the 4th power would be 16, because 2 times 2 times 2 times 2 is 16, and x to the 4th is just going to be x to the 4th. Oops, sorry, I don't know what's happening. And this is multiplied by y, and since we're raising an exponent to another exponent, we multiply it by this power of a power rule, so we get y to the 8th, because 4 times 2 is 8. Okay, great. Now we have a negative exponent. We talked about this up here. This is just going to be equal to 1 over a to the m power. Hopefully you can see that m. Okay, so in this case, when we have 7 to the negative 1st power times x and all of that to the negative 2nd power, we'd write this as 1 over 7, this is going to be hard to write, 7 to the negative 1st times x to the 2nd. And so we can simplify this. I'm going to actually do this in 3 steps. This is going to be equal to, I'm going to separate these two. So I'm going to distribute this squared to both the 7 to the negative 1st and x. So essentially we're raising an exponent to another exponent. So we're multiplying negative 1 and 2. So we get 7. Oh, jeez. I don't even know why it's like that. Sorry about that. Move 7 to the negative second power times x squared. That's all under 1. And conversely, when we have this property, a to the negative m power is equivalent to 1 over a to the m, I could also say 1 over a to the negative mth power equals a to the mth power. I'll just write this as a to the mth power over 1, or just a to the mth power. So it's essentially what it may be easier to think of, especially once we get to more complicated problems, is this negative exponent just allows us to put it on the numerator when it's already on the denominator, or on the denominator once it's already on the numerator. So just switching back and forth. So in this case, we can move this 7 to the negative second power up to the numerator to say 7 squared over x squared. So we get rid of that negative exponent. 7 squared is just 49 over x squared. Okay, great. Now we have 0 exponent. We already talked about this. Anything to the 0th power is just 1. So I don't even care what's in here. I know it's raised to the 0th power. That's equivalent to 1. Now, quotients of powers. Well, I want you to think about this. We have quotient, which has to do with division. And up here we had product, which has to deal with multiplication. They're sort of like the opposite of one another. Here, when we multiplied two exponential terms, we added the exponents. Now, here we're dividing those two exponential terms. What do you think we're going to do with the exponents? What's the opposite of addition? Yeah, so we're going to subtract. So we do a to the mth power minus n. So in this case, how I'd write this, first we just want to simplify. 6 over 216 should just be 1 over 36, because 216 is 6 cubed. And now we have x to the third minus, since we have x to the third divided by x to the ninth, we do 3 minus 9. So that would give us x to the negative 6th power. Again, we don't want negative exponents. We'd switch that down, bring it down to the denominator. We have 1 over 36 x to the 6th power. In this situation, it also might be helpful to think of, let me just write this out again. If we were to have x to the third over x to the ninth, for some people, it may be easier to think of this as x to the third and x to the ninth as x to the third times x to the 6th, because again, we add those exponents and we get 9. We can just cross off these. Or like subtract 3 from 9 and just keep that down here instead of having negative 6 on the numerator and then having to bring it down there. So I guess like some kids think of it better as whichever exponent is greater, whether that's on the numerator or the denominator, you just subtract the other value from it, if that makes sense. Some of these things will make more sense once we put this into practice. Okay, so power of a quotient rule. This is like here we have power of a product, here we have power of a quotient. So for a product, when we had the same exponent and we were multiplying two parts within it, we multiply those two terms. Here, what do you think we're going to do? Well, this is the same thing as saying a to the mth power over b to the mth power. So for example, in this case, we want to have 4x to the negative second power, and all of that over 7y cubed to the negative second power. When we just want to simplify, remember we have to distribute this to both the 4 and the x. So we have 4 to the negative second power, x to the negative second power, over 7 to the negative second power, and y we have to multiply negative 3 times negative 2 to get negative 6. Now all of these are negative exponents, so in hindsight I probably should have done that negative part first, but essentially what we do is we switch all these. So I'm gonna just take the reciprocal and flip everything. So have 7 to the positive second power on the numerator, y to the positive sixth power on the numerator, and 4 to the positive second, and x to the positive second on the denominator. I essentially did 4 steps right there. Then here we can just evaluate to get 49 y to the 6th over 16x squared. I don't believe there's any way we can simplify that any further. Okay, so now let's implement some of these. Learning from this problem, maybe let's just do this negative third part first. So we have power of a quotient rule in this case, something that looks like this problem over here. So I'm going to first flip these. So taking a negative exponent is like doing 1 over whatever exponent. It also is the same as taking the reciprocal, which means flipping the numerator and the denominator. You know what, I'm just going to write this out the long way, because just so you understand it first. So essentially, if we're doing 1 over something, so we'd do 1 over, and in this case it'd be 2r to the negative second, 2r to the negative second, I'll just leave it together in this case, 2r to the negative second, or no, you know what, I'm going to switch this up. So this is the same thing as 2r to the negative second to the negative third, and x cubed to the negative third, if that makes sense, okay? I know this is getting kind of messy. So we raise this to the third, and x cubed to the third. Right, so I'm able to have a positive exponent here because I'm putting 1 over this entire term. What we can do is multiply the numerator and the denominator by x to the third to the third. And this just gives us x to the third on the top over 2r to the negative second to the third on the denominator, because these two cancel out. Okay, and essentially what you can just do, once you get to this point, you don't have to do all this, just remember it's taking the reciprocal, so we can flip the numerator and the denominator to have positive exponents. Here we have x to the third, if you could see with my bad handwriting. So since we have a power of a power, like we have up here. We multiply the two, so 3 times 3 is 9, x to the 9th. And now we have 2 to the 3rd, which is 8, and r to the negative 2nd to the 3rd. So again, power over power, we multiply negative 2 and 3, we get x, or sorry, not x, r. R to the negative 6th power. And we don't want negative exponents in our answer, so we do x to the 9th, and we bring this r to the negative 6th up, somewhere there, and we get an answer like that. Okay, so now this looks more complicated, but it's actually not that bad. Let's start by multiplying these coefficients, so 4 and 6, we get 24. Now we want to look at for all our x's on the numerator, and we're multiplying both of these terms. So when we're multiplying two terms with the same base, what do we do to the exponents? We add them. So for x, we have x to the negative 3rd and x to the 7th. So what's negative 3 plus 7? That's going to be positive 4. We have y to the 3rd, y to the 3rd. Again, we're multiplying, so we add the exponents. 3 plus 3 is 6. And all of this is over 8, x to the 5th, y to the 6th. So here we have 24 over 8, which is just equal to 3. And we have x to the 4th over x to the 5th. So we can essentially just subtract 4 from 5 and get x to the 1st, which is just x. And then we can cancel out. We have y to the 6th over y to the 6th. So we can just cancel those out since they're the same value. So here again, hopefully that makes sense how I'm subtracting 4 from 5. Let me do this. X to the 4th is just x times x times x times x. Maybe I'm over explaining this, but I just want to make sure I don't skip over and assume anything. This is just essentially to this, or essentially equal to this. It's just written out really longhand, I guess. So we can cancel out each of these x's one by one, and then we're left with the x on the numerator. So this is equal to 1 over x. And that's essentially what we just did. We're subtracting 4 from 5. We're canceling out 4 x's in the sense of x times x times x times x from both the numerator and the denominator. So see, this is something that looks super complicated, but it's really equivalent to something pretty simple. Okay, so now let's work through some of these. Here we have a to the negative 1st times 3a to the 4th times b squared. We're multiplying two terms, exponential terms, with the same base a. So we just add those exponents. So what's negative 1 plus 4? That's going to be 3. So we have a to the 3rd, b squared. Nothing else we need to do. Here we need to raise 4x to the 4th to the 2nd power. Remember, we need to distribute that to both the 4, so it's 4 squared. And then that x to the 4th too. We're going to use power over power, so we multiply those two exponents. 4 times 2 is 8. 16. 4 squared is equal to 16. We just have x to the 8th. Okay, here now we have 2 over 4, which I'm just going to write as 1 over 2, just to simplify. And conversely, when we have a negative exponent and we want to get rid of that, we would actually, so remember how I said we subtract 4 from 5? So we do 5 minus 4. So instead of x to the 4th over x to the 5th, this is equal to 1 over x to the 5th minus 4. Well, here, m to the 3rd over m to the, oh, sorry, all my m's look like n's. This is going to be equivalent to m to the 3rd minus -1 over 1, if you want to put that, which is just equal to 4 since we're subtracting a negative. So m to the 4th over n to the -3rd. Again, we want to move that n to the -3rd up to the numerator. So we get m to the 4th, n to the 3rd over 2. This one's a little wonky, but the same, essentially one thing I just want to stress is the same rules apply, even if it's negatives or it looks weird or maybe it's fractions, the same rules apply. Okay, we'll do this one real quick. We have x to the 0th power, y to the 0th power. Anything to the 0th power is just 1. And 1 to the 4th is just going to be 1. 1 to whatever power, to the millionth power, is just going to be 1. Since 1 times 1 is 1. And you can do that however many times, you're still going to get 1. Okay, anyways, we have, I'm just going to write, instead of all this, 1. So right now we have 1 over 2x to the -2nd y squared, and all of this to the -3rd power. So instead of having that negative exponent, I'm going to take the reciprocal. I'm going to do 2x to the -2nd y squared over 1 to the 3rd power, which we don't really need that over 1 anymore. But we'll keep it actually, because we're going to have to do something with it. So now we distribute this, cube this to the 3rd power to each term. So 2 cubed is going to be 8. We are raising a power to a power in these two terms. So we have x to -2nd to the 3rd power. We do -2 times 3. We get x to the -6th power. We do y squared times to the 3rd power. So we do 2 times 3. That gives us y to the 6th over 1. So in this case, we have a negative exponent. So we want to get rid of that by moving that x to the -6th power down here. Okay. Let's do 2 more. You know what? Let's do this one and this one. So, okay. So in this case, this is going to be equivalent to 2. I'm just going to bring that 2 out front. We have x to the 6th power, or x to the 3rd power. My bad. Let's start with this second term, okay? Lord, my bad. Yeah, I don't know what I'm doing. I'm just out of order. It's too early. Okay, so we have 2 y x to the 4th to the -2nd power. I'm going to get rid of this -2nd. This is essentially over 1. So what I'm going to do, I'm going to take the reciprocal. I'm going to do 1 over 2y x to the 4th and all of that squared. So this is going to be equal to x to the 3rd, y to the -1st times and then this is essentially equal to, I know this is messy, but this is essentially equal to 1 squared over 2y x to the 4th squared by this rule, power of a quotient. So what we're going to do from here, we have to distribute this square to both terms. So we're going to have 1 over 2 to the second power is just 4, y to the second power is just y squared, x to the 4th power is just x to the 8th. Okay, great. And here, I'm actually just going to rewrite y to the negative 1st power as 1 over y, since y to the negative 1st is the same thing as 1 over y to the 1st. Okay, great. So now we just want to combine everything, and we get x to the 3rd on top. And on the denominator, we have y times 4y squared x to the 8th. And this is equal to, so I'm going to first, I'm first actually going to deal with these x's. We can subtract 3 from 8, right? 8 is the greater number. So we subtract 3 from 8, and we get 4x to the 5th, right? Because 8 minus 3 is 5. And then we have two exponents, or two exponential terms with the same base, y. This is essentially y to the 1st. So we add 1 and 2, and we get y to the 3rd. Okay, then we'll do 7 real quick. Here, let's combine everything on the top. So we have 2, and then we have x to the 3rd. And whenever we have an x by itself, that's the same thing as saying x to the 1st, or any variable to the 1st. And since we're multiplying those, we want to add the exponents. So we do 3 plus 1, and we get x to the 4th. And here we have to add negative 4 and 2. So we have y to the negative 2nd power. And all of this is over 2y to the 4th to the negative 3rd power. So actually what I'm going to do, since we have something to the negative 3rd power, like we can do with, where's the case? Like we can do with, say we had a negative x to the negative 6th, and we move that down here. I'm just going to do that with this entire term, 2y to the 4th. I'm just going to bring that up to the numerator. So I'm going to say 2y to the 4th cubed, and all of that over 1. And now I'm just going to simplify this more. We still have 2x to the 4th. And actually now I'm just going to bring this y, or you know what, I'm going to leave that up there. Never mind. And then we're going to distribute this cube to both the 2 and the y to the 4th. 2 cubed is just going to be 8. And we multiply the exponents since we're doing power of a power. So 4 times 3 is 12. And all of that over 1. So 8 times 2 is 16. Now we just want to add. We don't have any other x's, so we have x to the 4th, y to the negative 2nd times y to the 12th power. We just do negative 2 plus 12. We get y to the 10th. And that's going to be our answer. Okay. Hopefully this makes a little bit of sense. You'll get, the more practice you get, the more reps you get, the more comfortable you'll be with this subject. And it's a really important topic because sometimes later in math, you're going to have these really complicated expressions or equations, and being able to simplify it to something much more digestible is going to be important. Okay, if you have any questions, first and foremost, go to your teachers, go to your classmates who, know what they're doing, get through it together, make sure everybody understands. Definitely go to the tutoring center, use me as a resource. That's why I'm here. And also just use the internet. YouTube is a great way to learn new things, reinforce certain concepts, just get more practice. Okay, see you later. Bye.